as a freshman in 1968, and I've been teaching some version of this course for 30 years. This is Dr. Simone Belmar. You can remain standing if you like, okay. Simone was a graduate student in this department. He got his PhD here, and he's now a lecturer in the department. He and I do some consulting together. My office is right across the hall in room 4140, right on the Great Court. Dr. Belmar, we put in the basement, try to hide him in the basement. Actually, he has a nice office too. And he actually does have an MIT extension, but he's never there, so you might as well call it cell phone. And he's pretty responsive. And okay, so this course started out 30 years ago as a course in welding, which is how I got my tenure, okay, by becoming a welding expert. But then in 1990, they started the manufacturing program here, and so I kind of expanded the course, and we did more than just welding, and we did manufacturing-related stuff, and that's why some of you come from course 2. And then in 1998, Professor Masabuchi, who would have been in course 2, he was actually in naval architecture at the time, but he retired finally, quit teaching his welding course, so I started teaching a materials course. There's a couple of chairs up here. There's also a couple of chairs right here. You can find a, right? And anyway, about 5 years ago, 6 years ago, Professor Hsu was head of the graduate program. He said, well, Tom, we want you to teach more than just welding. Well, I'd been teaching more than welding, but everyone just thought that I'd been teaching just welding. So he asked me to teach I said, okay, I'll teach structural materials. So what we did, and I won't go into all the details of why, but okay. What I did was I decided that I would teach one 12-lecture module per year, and since I had already been videotaping my classes, I'd teach some new modules rather than welding modules. There are 3 welding modules, and a 12-unit course is officially about 36 lecture hours. And if someone wanted to study welding, and no one wants to study welding anymore, everyone's interested in nanomaterials and things like that, they could. But we've added different things, and Dr. Belmar has been helping me. This past spring, I was on sabbatical, and so I had 3 people teach 3 modules. Steve Lyons is a practicing attorney in downtown Boston, and he taught 12 units, 12 lectures on law and technology. Intellectual property, copyrights, trademarks, patents. Basically tells you if you want to be an entrepreneur, you ought to take this course, okay, this module, okay? Structural materials, Dr. Belmar's a mechanical metallurgist, if you will. He's broader than that, but I mean his specialty is mechanical behavior of materials. His thesis was in fatigue and fracture with a guy who went on to be head of the National Science Foundation and now is president of Carnegie Mellon, was his thesis advisor. I had a former student, Neil Jenkins, who had been an MIT lifer, came here as a freshman, did a PhD with me on welding fume, jointly with Harvard School of Public Health, and then he decided he wanted to get an MD. Why not? Okay, so he became an MD, and so he was around, and he decided he wanted to teach a course on, we called it non-destructive evaluation of the human body. When you go to a doctor for an exam, what does his doctor look for? Well, you know, if I had a broken weld, we might x-ray it or we might do ultrasonics. Well, it turns out this is basically, you're getting from an MD who's also a PhD material scientist, what a doctor looks for, okay? And he senses things like smell, okay, taste, okay, not that he licks you, but that's nonetheless. Anyway, so that's a 12-hour module. Or material selection is actually kind of my favorite module now for undergraduates. It gives a broad view of materials where I debunk a lot of the current mainstream thinking of materials, and I'll go through some of that. Materials processing, Dr. Belmar, well, he did structural materials. He did materials processing before. You're going to basically do, he's going to talk a little bit, but he's going to do some materials processing again this semester.
Yep.
Welding metallurgy, I told you about that. Structural materials, which is a version of what he did in 2015. Materials selection, again, I repeat some of these. Environmental and mechanical behavior, which involves corrosion and some other things. Welding, materials, structural materials. Anyway, codes and standards, which is sort of unique. I developed that course because in terms of general engineering, students need to know something about codes and standards. When you get out there and do engineering, you're going to be limited by the codes and standards that are out there. And it's sort of a question of, do the codes and standards that have been developed over 100 years, do they promote, well, they promote safety in engineering, but do they stifle innovation? Because they tell you certain things you can't do, okay? And then deformation process. Anyway, there's a whole list of these. There's about a dozen different ones, and so you have to take 3 for the course. Your choice. We're only lecturing 2 of them live, so one of your 3 has to be something that you watch off YouTube. And if you go to the website, and I think something on Stellar, but anyway, if you go to my website, eager.mit.edu, it will take you as a link, and you're going to have to watch these on your own. Now, one student's evaluation one year said he watched the lectures while he's fixing dinner. Okay? So you can watch them whenever you want. You have to have them done by the last day of class, because that's when the registrar, since I don't have a final exam, wants me to turn in the grades. Okay? But it depends on what you're interested in. If you're interested in nuclear materials, you could pick some things that are more specific to nuclear materials. And if you don't know, we can talk about what it is. A lot of the undergraduates, I think they've heard about this course just because I tell stories. Okay? I have lots of stories. Okay? I'm writing a book about 50 years at MIT, and I got a few years to complete it, but I got lots of stories, and students like the stories. So this year, I'm going to talk about what is engineering, but before I start talking about my live module this term, you want to talk about your live module?
No, I can do it when you're done, I think, because we're going to have to switch.
Oh, okay, fine. Then, okay, let me tell you some of my... I am not necessarily a conventional thinker about what things are done at MIT. Well, first, I guess I ought to tell you what's required in the course. Required to take 3 modules, 36 hours of listening to one of us or other people lecture. Your choice. Design your own course. It's about structural materials, generally. My stories have lots of things to do with nothing that has to do with structural materials, but they do have some things that have to do with other things. I've decided to do this one as what is engineering, okay? And the reason is I do a fair amount of forensic analysis, and the students always wanted me to, they've been asking, well, why don't you teach us something about your forensic stories? Well, I'll tell you some of the forensic stories, but I can't really teach you how to testify on tape because some attorneys would be listening. Believe me, they would watch 100 hours of my lecturing to get a few zingers for me, okay? So if I have certain secrets about how to testify or how to do a study, I don't want to broadcast them, okay? It's sort of proprietary information. Now, over the time, I'll tell you some of those things, which is why the students were sort of intrigued by some of those things. So far as the requirements in the course, come to class or watch the modules at your own time. Usually we'll get them uploaded within about 48 hours. Right? Yep, okay. So you can, even if you miss this class, 2 students already came in and they got a conflict. They got another class and they wanted to go see what was going on, or they wanted to know, should they stay here? I said, you know, you can watch this lecture 2 days from now and they can decide on what they want to do. You have to do a presentation. The presentation should be no more than 10 minutes. If it's more than 12 minutes, I'll stand up next to you until you quit talking. which if I intimidate you enough, you will quit talking. The topic is anything you want. Literally, anything you want. You could tell us about nuclear materials. I've had, of course, 20 people before, and they've talked about, zircaloy, why use zircaloy as the cladding for the nuclear fuel. They've talked about Davis-Besse incident, which was a big near catastrophic failure of a nuclear reactor in the United States. I teach the welding metallurgy now to the Navy officers in course 2. For about 120 years, the U.S. Navy has been sending people, kind of 30-year-old lieutenants and whatnot, back to get master's degrees at MIT, and I teach them during the summer. So that's why if I put up the list, you'd see some summer things. But it can be on any topic you want, okay? We've had people do flying buttresses for Gothic cathedrals, okay? And we'll talk some more about the topic, but it can be any topic you want, because I found if I let you talk about what you want to talk about, you'll do a much better job, okay? And actually, you will have to attend a number of these. Looking at the size of the class, last year we had about 40 students, and I had to watch all of them, okay? But I asked the students to attend half of them, okay? And we the schedule is such that Dr. Melmar or I will probably be lecturing every day, Monday through Friday, 5 days a week, at 9 o'clock here. Our order of presentation will not necessarily be consistent. He wants to do Mondays, Wednesdays, or Fridays. Awesome. Yeah, because he has other things often on Tuesdays and Thursdays. In general, over the term, we only miss sometimes 0, 1, or 2 classes. And at that time, you can have the day off. You can sleep in, okay? You can sleep in anyway. You don't have to come to class. You can just watch the movie on your own time. But if you don't come, you don't get to ask questions. There's another chair right here, or right there, okay? And that's what I have to do. I have a different philosophy about teaching. I think the way we teach in this country is terrible. People, and I started to realize this when I was teaching undergraduates here at MIT, but particularly when I saw one morning, my children are all grown now, but this is 20-some years ago, and I saw I was having breakfast about 4 a.m., and they'd left their math book out, and they had 2 pages on every topic. There were about 150 topics on mathematics. 2 pages on exponentials, 2 pages on derivatives, 2 pages on the binomial theorem. I mean, I didn't know that mathematics came in 2-page modules, okay? What they're doing is they're training them to take the SAT test, okay? They're not educating them. And what are they doing at MIT? We do the same thing. We give you problem sets, okay? And I hated problem sets. The only thing I hated more when I was a student was 3-hour final exams. I used to decide what courses not to take depending on whether they had a 3-hour final or not. Sometimes you had to take it because it was required for your major, but nonetheless, I consider the problems you get in problem sets to be artificial. After all, how many of you have ever had a problem given to you that had extra information or insufficient information? You have. A couple of you have, okay? But most of the time, you get just the right amount of information in that problem, right? And if you're smart, even if you don't know how to solve it, you can often figure out how to use all the information, and you can get the right answer if you just use all the information somehow, right? Well, that's not the way the world works, okay? So, aside from the fact I hate them, I also have found it's very difficult. Very difficult. Students can't imagine how difficult it is to write a good problem that's not ambiguous in some way, okay? And essay problems, oh, gee. First of all, I have to decode your handwriting, okay? And second of all, I have to decode your grammar, and if I can then try and figure out what you're trying to say, I could then maybe give you a grade, okay? But what do these grades really mean? Okay, well, if everybody at MIT had my attitude, I would probably teach the way they do. But in fact, I think the way we teach is terrible because all you're trying to do is see if you can get a good grade. And you don't want to ask questions in class because you want to make sure the professor covers everything that's on his list, okay? Well, I have no particular list when I lecture, okay? So you can interrupt me, and I'll digress because that's not what's important. And in fact, I actually have some slides here about philosophy of education. There is, some things are already up on Stellar. There's something I wrote over 10 years ago in the faculty newsletter called Leadership Management and Education at MIT. It goes on for about 3 pages after this. But I would encourage you to read it because I basically talk about what makes MIT unique, okay? There were 5 things. I guess 5 things. MIT has 1 class of students and faculty. MIT is intense, has a culture of creativity, has unusual breadth, and it displays integrity. And I try to defend all of those, but you're not gonna be able to compete with your classmates, okay? You know, most of you, first of all, you don't need to prove to me you can take a quiz. You're in the top 0.03% of the population in native intelligence, okay? You wouldn't be here if you couldn't take a quiz, right? And do well on it. And look at all the stress it engenders. You know, I thought I was going to flunk freshman physics. When I got a 30, when class average was 60 in my junior thermodynamics course, I was shattered, right? You know, how many of you have had that experience? Well, most of you, okay? The problem is, as I say in that article, MIT students were at the top of their class. They learned in high school to compare themselves with other people on their science and technology and engineering and math abilities. And they come to MIT, and the problem is, on average, they're average, okay? And so you learn to think of yourself as just sort of average. Well, you're not average. You're at the top, okay? And you have to, MIT, I point out in here, they did a study about 20 years ago of graduating seniors. And the seniors pointed out they had less self-confidence when they graduated than they did when they came to MIT. And that's the tragedy of the MIT education, okay? We only admit 1 class of students, and we ram you through freshman year. You have no choices, but because we only admit 1 class of students, we can do that, okay? And you're all uptight, and quizzes just make you more uptight. And we now have 52 deans who say, oh, we got to treat the students with more, more genteel and everything. Well, most of the faculty aren't going to do that. But most of the pressure at MIT is self-inflicted. But there's not a lot of pressure in this course. You get to come and give a presentation, and you got to listen to some lectures and stuff. Part of my philosophy on education is some of the things I read by Robert Hutchins. Anybody know who Robert Hutchins was? He was president of the University of Chicago after World War II. He was the author of the great books of the Western world. He was a great liberal education scholar. Okay, the object of a liberal education is not to teach the young all they will ever need to know. It is to give them the habits, ideas, and techniques they will need to continue to educate themselves. Thus, the object of a formal institution liberal education in youth is to prepare the young to educate themselves throughout their lives. So there's no particular information you need to get out of this course. But I think I can guarantee you will learn some things in this course that you didn't know before. But I don't care what you learn. Doesn't matter. Because in the end, you've got to learn that you can go and take a topic you've never known anything about, and within about 8 hours of studying it, you can become a world expert. Okay? You're smart enough to do that. Hutchins also said, the mind is not a receptacle, information is not education, education is what remains after the information that has been taught has been forgotten. So I don't remember what was in most of my early classes. There's a chair right there if you want. There are some sign-in sheets if you'll have a chance to do that. So I can't tell you, this is in part of this faculty newsletter article. I've been through a number of faculty meetings here where they're talking about student curricula and they say, well, the students need to learn this before they graduate. Well, if class average is 70, they obviously didn't learn 30% of what was needed, right? None of this stuff is needed. Most of you will not work in the field of your degree 5 years after you graduate. In fact, when I was department head, we had ABET accreditation, and I was meeting with the professor from University of California, San Luis Obispo, who was the person doing the accrediting for the materials department, and he says, well, you don't produce engineers anyway. I said, what? He says, sure, 5 years after your students graduate, they're all going to be managers. And that's true. He was absolutely right. You're not going to be a draftsman sitting at some drafting table, drawing something, or actually not a drafting table anymore. It's a computer screen. There's going to be a lot of conflicting ideas out there, and the test of a first-rate intelligence, and I believe you're all first-rate intelligences, is the ability to hold two opposed ideas in the mind at the same time and still retain the ability to function. One should not, for example, be able to see that things are hopeless. One should, for example, be able to see that things are hopeless and yet be determined to make them otherwise. Okay? You have to keep working at things to get around the problem. And that's part of what engineering education is all about. There's a couple of other things that you can read before I turn some of the time over to Dr. Belmar. Aside from the faculty newsletter, we're going to talk about communications. Because if you don't communicate your ideas well, you're not going to be listened to. Okay? And that's why MIT has a communications requirement, and actually I think it's working after 30-some years. It actually is starting to do pretty well. And to give you an example of some of the things I just said, I was asked in late September of 2001, right after 9/11, by the editor of a journal, metallurgical journal, if I would write an article. Actually, he didn't ask me, he asked Professor Clark. And Professor Clark said, oh, you ought to get Professor Eager to do it. So he asked me, and I was so sick and tired of reading newspaper accounts about how the steel melted in the fire of the airplanes. Well, anyone who's ever been to a fire scene knows that steel doesn't melt in a fire. If steel melted in a fire, why did we need Sir Henry Bessemer in 1856 to tell us how to melt steel? Okay? The typical temperature of a fire is about 1,000 degrees centigrade. Steel melts at 1,500. I've seen steel derricks where they had a blowout at 10,000 psi of natural gas from the gas well in Oklahoma, and it catches on fire for 3 days, and the flames are 300 feet in the air. The whole derrick is engulfed in flames for 3 days, and the steel didn't even transform to austenite above 900 centigrade. Okay? And I'm reading these great scholars, the newspaper reporters, talking about, or they interview great experts. Well, the steel melted in the fire. Anyway, so he asked me to write an article, and so I often describe this as, what can you say when you know nothing about a subject? I spent 3 hours researching and writing this paper. Okay? It became, for about 7 or 8 years, the #1 hit on Google if you typed in WTC collapse. Within 3 or 4 months, I was the expert in Washington, D.C. on the Trade Center collapse. Okay? I told you, it only takes a few hours and you become a world's expert. Okay? All I did is talk about the same principles that I used to teach in sophomore thermo. Okay? Or the combustion I teach as part of my welding course, because welders use torches and things like that, right? And there's certain fundamental principles of combustion. Like, I know the maximum temperature, 80 back flame temperature of hydrocarbon fuels burning in air. I can do it in pure oxygen even easier, okay? But anyway, so this article, and then What happened? The truthers, yeah. How'd you know about the truthers?
The last time I looked you up, this information was most of what came up.
That's what most of comes up. I'm on Wikipedia in German because I wrote this article. I spent 3 hours writing this article, which was the shortest time I've ever spent writing an article, and I've had more comments, good and bad, about this article than all of my other publications combined. Okay? Why? It's on a topic that is of interest to a lot of people. But more importantly, I wrote it with the idea, this is part of the communications thing. When I was writing this, I was thinking of a high school science student. And I didn't write anything in there that was more complex than what a good high school science student could understand. And you ought to read it with that in mind, and with also in mind, I'm not talking about anything. I did get some information. Some guys in civil engineering had given a seminar. I couldn't be there, so I got permission from one of my graduate students to videotape it, and I watched their 1 hour lecture. That was my preparation. Then I sat down. It took me 2 hours to bang this out. Okay? So, but because, and I'll tell you some stories, so I'm going to let Dr. Belmar start. Go ahead, Simone, you can start switching over if you like. Because I wrote it so people could understand it. I didn't get too complex. I kept it simple because I'm sort of simple. I can't understand it so much myself. And I didn't try to snow people, okay? One of the problems with the way we teach is typical university professors, and this goes back 400 years, become scholars on a very narrow topic, okay? And as a result, when they get up to teach, they teach what they know, a very narrow topic. And as we say, how many of you heard the saying, you learn more and more about less and less until you know everything about nothing? Okay? Well, that's what I learned when I was a student here. The professors, and there are actually articles written by psychologists about this, a lot of professors get up and try to hand down the knowledge and tell you how complex the world is. Because otherwise, they've been spending 40 years of their life making something that was very simple complex, and that doesn't go very well for their ego. I prefer to teach you things in a way so it comes out of your common sense, okay? You actually know most of what I'm going to tell you, but you haven't put it together. A lot of engineering is looking at patterns in the world and recognizing those patterns, okay? And so that's what I'm going to do in What is Engineering. I'm going to hopefully help you gain some of the tools that they don't usually talk about. That's what this module is going to be. But if you're more interested in selection of materials or structural materials or welding or deformation processing, which is forging and all those other things, you can take 36 units of things and not come to class.
I think you should take Professor Hager's class.
Wow. Anyway.